this video, we are going to finish our discussion of section 2.6, 2.4 and 5 over exact equations. We're going to ask ourselves, what if we check if a DE, it looks like it may be exact, or maybe it's kind of close, but is there a way to manipulate it to make it exact? Well, I'm going to show you there is. I'm going to show you how this works to show one and then the other, and then I'll show you what to multiply by, how to get it. So we're going to show that this mu in example 5 down here is an integrating factor. So first thing I'm going to show is mxy, which is 2y minus 6x. If I take the partial, remember we do it with y, we get 2, right? If I do nxy, which is the other function in front of dy, 3x minus 4x negative 2, y to the negative 1. If I take its, I'm going to do some arrows here, its partial with respect to x, the other variable, I get 3. Then I get 8x to the negative 3. It's definitely not exact, right? Not exact. But now, if I multiply the equation by their integrating factor, so I'm going to do that for each one, 2xy to the third minus 6x squared y squared dx plus 3x squared y squared minus 4x to the third y to the 1 dy equals 0. So I'm going to call these a different name. We'll call them m1 of xy is equal to 2xy cubed minus 6x squared y squared. We're going to show now, because of the integrating factor, if I do m1 with partial to y, we get 6x y squared minus 12x squared y. N1, the new function that we have, which is 3x squared y squared minus 4x cubed y. If I take the partial with respect to x, we get 6x y squared minus 12x squared y. Therefore, our new DE is exact. So what we just have shown is there is a way to manipulate equations by multiplying by an integrating factor. This is one of those useful things, not exact equations to be exact, but this idea of an integrating factor is what will be useful if you use DE in your fields. So what is this integrating factor? Where does it come from? We're not going to go through the theory because it's pretty heavy and outside the scope of the course. I'm just going to give you the integrating factor. The integrating factor is in this first box here. It's this piece. That x means e. It's just e to that, and that's it. The thing in the bracket is the power, right? It's either that or the one below. How we determine is we either look at this or this. And if one of them gets rid of the variable, the other variable, like meaning it leaves me with just x or just y, that's what we want to use. That'll tell us that these will work. Okay, so let's do an example of this here. So let's write down each thing. We have m is, so mxy is 2x squared plus y. Okay, so if I do, let's call this m1. So m1, if I take its partial with respect to y, it's 1. Now let's try n1 xy. We let that be the other function. We're going to show that it's not exact. And we do n1 with respect to x, we get negative 1. So that tells me that it is not exact. So we're going to look at both of these. Let's consider both. So the first one I'm going to consider is, let's do nx minus my over m. That's the second one. I plug all this stuff in. Okay, so that's 2xy minus 1 divided by 2x squared plus y. If I work all this out, I can manipulate some. I'll show you where I got to here. But it doesn't really help me out much at all, right? The x's and y's are still there. That tells me that that doesn't work. So what I do now is I go the other way, my minus nx over n, And if I plug all this in now, 1 minus 2xy plus 1 over x squared y minus x, right? So I get a negative 2xy plus 2 on top over x squared y minus x. And then we can actually factor it. I'm going to do it here. 2 on top. So I get xy minus 1. I'm looking at the wrong one. Yep, let's go back. Hold on one sec. I messed up there. This should be 1 minus xy. There we go. Right, and then over, and this is x. If I factor out x there, I got xy minus 1. What this does is just flips the sign when they're reversed like that, so I'm getting a negative 2 over x. So because I have a negative 2 over x, there's no y, this tells me I can find an integrating factor. So my integrating factor, mu, is going to be e to what's there, negative 2 over x. Let me move that down for my, if I ever send this out, dx. All right, so I got e, and I got negative 2 integral of 1 over x dx. This is e to the negative 2 ln of absolute value of x. It's an integrating factor. I know I don't have to do plus c. This gets me x squared. I can drop the absolute value because negative squared, because it's a square. So there's my integrating factor. I can now multiply my dE that we started with by that integrating factor. So let's do that. Okay, so let me write down the original dE here since we don't have it on the screen. Hold on, I lost it here. Okay, here we go. It's 2x squared plus y dx plus x squared y minus x dy equals 0. If I multiply everything by the x to the negative 2, I get 2 plus x to the negative 2y dx plus y minus x to the negative 1 dy equals 0. Right, now what we're going to do, I'm not going to solve this dE, but I'm going to show you that now it is exact. So let's call this M2. So M2 x and y is 2x to the negative 2y, the plus sign in between. So if I find M2y, we get the 2's gone, and then we just get x to the negative 2. Into xy is now that other side. That's y minus x to the negative 1. We take this one into, remember we do it with x, and you can see the negative 1 comes down, making a positive, and then leaving us at negative 2, meaning they are the same. So the new dE is exact. So I am going to leave it here because I don't want the video being too long. You would just solve now using the method of solving exact equations.